Now bear in mind, all of this was coming out in the late 19th century, when Lord Kelvin made a number of real gaffes. He was a brilliant physicist, but boy, if he wanted to make a mistake, he did it flamboyantly. And this is one of them. There is nothing new to be discovered in physics now. And he would tell his graduate students, don't go into physics anymore, all the fun's over. Go into something else. Biology looks pretty good, but we did it. We finished. Right? This is about 20 years before Max Planck started quantum mechanics, 25 years or so before that guy, what was his name? Einstein. And then all their colleagues, Werner Heisenberg, Niels Bohr, and so forth, there turned out to be something new after all. But that was not the assumption in the late 19th century. It looked darn good. It looked like Newton had been so brilliant, so brilliant, and the ensuing couple of centuries had so unpacked it so beautifully. And then the integration, this whole principle of conservation of energy was such a great element to be introduced there. Darwin seemed to really have nailed the whole nature of life and its evolution. It seemed like, aha, we've got it. That was exactly the attitude of the medieval scholastics in the early 17th century. Aha, we've got it. There are questions we no longer need to ask because we already know the answers beyond a shadow of a doubt. So don't doubt and don't question. But I want to come back to this natural world. Natural world. Often people, when they want to use a more benign term than scientism, which has actually a pejorative connotation to it, they'll use the word naturalism. Naturalism. I wanted to be a naturalist when I was in my teens. I wanted to be a wildlife biologist. Naturalist. That sounds kind of nice, doesn't it? Rather than, do you really want to be a naturalist or an unnaturalist? I want to be a naturalist myself. I want natural food. I want organic food, not unnatural food. None of that genetically cloned stuff. So naturalism has a nice ambience. And natural world. So what is this natural world for which science, is our sole source of knowledge? Well, it turns out there are many notions of what this natural world is. Now, what they're all agreed, if we look at Richard Dawkins with his whole diatribe against theism, and Daniel Dennett, the same thing, Sam Harris just going ballistic on this theme, and Hitchens was the latest screeching voice against God. What they all agree is that we have to be naturalist here. What is this natural world? They know that what isn't true is supernaturalism. This is like heresy. If you're a supernaturalist, well then we're just going to have to excommunicate you. Because you're just not in our tribe. You can't be a scientist and be a supernaturalist. Because scientist means you're a naturalist. What is the natural world? Well, many people equate it with the physical world. That kind of that makes sense. Physical world, so space, physical space, time, matter, energy. That pretty well should do it, right? Physical. The problem with physical, the problem with that equation, is the very notion of the category of the physical is a moving target, and it's moving now. If we go back to the notion physical in Descartes' writings in the 17th century, that was one notion of physical. But as we move ahead over to Newton, now physical means something else, and his notion was somewhat different from Leibniz's. And then we keep on moving forward, we get into the realm of energy, of electromagnetic fields and so forth. Are they physical? Are they not? Gravitational fields, are they physical? What are they made of? Newton was deeply troubled by this notion. There could be empty space between the sun and the earth, and it would still hold this great big chunk of dirt, the earth, in the orbit around the sun, and it didn't. How did it do that? These gravitational fields. What in the earth is a gravitational field? The answer is nobody really knows yet. A curvature of space-time? That didn't satisfy me too much. So the physical, the very category of the physical, I think a crucial element here that is often overlooked is the very category of the physical, the demarcation between physical and non-physical, is created by human beings. Nature didn't whisper into the ear of the physics department at MIT, this is the real definition. No physicist prophets that just got it straight right down the pipeline from nature's mouth to their ears. This is what I really mean by physical. It's a moving target, and it moved no more radically in the history of modern physics, that is going back to Galileo, than in the 20th century, with quantum mechanics especially. Quantum mechanics. An unmeasured quantum mechanical system is described as a probability function, described mathematically by Schrödinger's wave equation. It's a set of probabilities. It's a complete mathematical abstraction, but you can measure. It's called a quantum measurement. And you move from potentiality to actuality. How can you measure a potentiality, which is a mathematical abstraction? We don't even need to go to quantum mechanics. Ever since 1887, the great Michelson-Morley experiment showed that there is no mechanical explanation for the propagation of electromagnetic fields through space. If there were an ether, it would work out really well, because then the ether would ripple, just like water ripples with waves passing through it. But if there's no ether, there's no medium to propagate electromagnetic fields, which means there's no mechanical explanation, which means the only way to describe an electromagnetic field is in terms of pure math. It's not some chunky stuff out there moving through space and rippling the medium space, going blah, 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 like that. So what's physical now? Is a probability function physical? Is a mathematical description of an electromagnetic field physical? Is dark matter physical? How about dark energy? Is that physical? How about the laws of physics? E equals mc squared, F equals ma. Are they physical? They're part of the natural world, aren't they? The laws, the mathematical law, are they physical? What on earth does it mean? And Werner Heisenberg made the comment that there have been two large motifs, or ways of understanding the physical, tracing back to Democritus. Everything boils down to chunky little things, atoms. To Pythagoras, everything, the whole physical world, boils down to mathematics. Werner Heisenberg, one of the great architects of quantum mechanics, said, the debate's over. If you're trying to boil down the whole physical universe to little tiny chunky stuff, you lost. Because quantum mechanics says it just ain't so. An unmeasured quantum mechanical system does not consist of little elementary particles with real location and real velocity prior to the act of measurement. It'd be really simpler if they did, but they don't. There's virtually complete consensus among quantum physicists that that is not the case. So what does the word physical even mean anymore? And what we know is it's become very ethereal, and what we know is there's no consensus. So that would be kind of limp, or just kind of leave you natural world equals something that we don't really know what it means. How about the objective world? Science is objective, right? That's its great strength. Galileo looking outwards, Darwin looking outwards, Einstein also looking outwards to configurations of space-time. Is that the natural world? What we can actually appears to us objectively, what's really out there? That's like saying the only good food is steak. If you want to believe that, that's perfectly fine, but what's wrong with Jell-O? That is, what makes the objective world more real than the subjective world? Just because you say so? Shall we hold a church council and just say, decree that the objective things are somehow more real than the subjective? It's not real, it's only in your mind? Are you out of your mind? What is more real than your sufferings and your joys, your hopes and fears, your thoughts, your aspirations, your memories, your sense of personal identity? What's more real than that? Human interrelationships, are they objective? What's more real than that? So that just seems to be sheer whimsy to equate natural world with objective world, as if we're just going to decree before we even start that the realm of the mind is not natural. Well, that's like, I don't know, saying some ethnic group is just inferior because we said so. They kind of look inferior, don't they? You know, pick your choice, Anglos, whatever. That's just whimsy. That's not even a scientific hypothesis. That's just like, whatever. If you want to play that game, that's like Parcheesi. Okay, make up your rules, but nature never said that the objective world is somehow more real than subjective mental events. That's just silly. But it does happen to be what physics, biology, chemistry are good at. So should we say the natural world consists only of what physics, chemistry, and biology are good at looking at? That's letting our very view of reality be defined by the limitations of our systems of inquiry. That's Parcheesi all over again. That's just a game. That's silly. How about just saying that the natural world equals the world of physics? Physicists might love that. If you want to just let us be the arbiters of all of reality, well, okay, just give me a raise. You know. But why should we say that? I mean, physics is a magnificent discipline, and it's gone through not only one, but now two great revolutions, starting with Copernicus and now the second one in the 20th century, which is not over, a very important feature here. But that's just like designating a certain group of people like a college of cardinals and saying, okay, you just tell us what's true. Well, okay, if that's what you want to do, but then just call it a church. And if you're just going to say that physicists get to tell us what's true and not true, then just call that a church. Nature never said that physicists have some kind of a priority over biologists or over psychologists. So that's just whimsy. Or so many people in the life sciences and especially the cognitive sciences leaning very heavily on neo-Darwinism, and by that I mean Darwinism with the marvelous advances since his time, especially in genetics, starting with Mendel right through the Human Genome Project, as if this defines, this is the very, now we know what's really going on. Well, I believe Darwin had brilliant theories, tremendous amount of truth in it, but to simply equate the natural world with that, I think, well, okay, it's just an opinion. If you want to have that opinion, fine, but why call that science? And finally, this is not an exhaustive list, but this is one that comes up quite frequently, and that is if anything has any impact on something we know to be physical. Let's take an example, the human brain. Human brain is physical. I mean, I would have no qualms about that. It's made out of cells, molecules, atoms, elementary particles, electromagnetic fields, electrochemical system. If that's not physical, then I don't know what would be physical. So the brain is certainly physical. That's clear. But now, shall we say that anything that can possibly influence the brain, which is physical, must be physical because it influences the brain? It's kind of like hegemony. You know, like here's a domain. If anything even touches our domain, then it's part of our domain. Why should we believe that? There were good reasons for believing that in the late 19th century. From the time of the mathematical formulation by Helmholtz, Hermann von Helmholtz, 1864 or something like that, the mathematical formulation of the principle of conservation of energy. It looked like the physical universe was absolutely hermetically sealed, that nothing could impinge upon the physical universe, not the Milky Way, not the human brain, two physical systems. Nothing could impinge upon it. Nothing could have any impact on any aspect of the physical universe unless it itself was physical, because if there was something non-physical impacting the physical, that would violate the principle of conservation of energy. So it looked very tidy. This really warmed the cockles of the hearts of people who embrace this as a central pillar of modern physics, and to some extent it certainly still is. It's a brilliant principle, and it's about as full of holes as Swiss cheese. And it's called the Heisenberg uncertainty principle, that goes for energy and time. There are, and this is not New Age physics, this is just core quantum mechanics, there are violations of the principle of conservation of energy. The shorter the violation, the shorter the violation, the larger the magnitude of the violation can be. So it's like if you steal from the bank, if you're really quick, you can steal a lot of money. If you're slow and lethargic, you only get $10. This is core quantum mechanics. It does not hold. It is not hermetically sealed. You can cheat. You can take quick withdrawals out of the physical universe, or you can insert. And when we have things like the placebo effect, what a mystery. That was one of the things they never saw coming. It shouldn't be there. If you're a good, strict materialist, the placebo effect just should never happen, and we should never have any double-blind experiments, triple-blind experiments. We would just say, take this, tell me whether it works. And it shouldn't matter whether the person has faith, belief, expectation, desire, has trust in the person who gave them the pill. It shouldn't matter. Because after all, it's just subjective. Your faith, belief, trust, and so forth, they're just subjective, right? They influence the brain. These feelings, the trust you may have in your physician, the feeling, that's a really cool pill, I bet that works. You know, or that looks like a really flaky pill, that's homeopathy, that's got like 1 out of 10 million parts, I doubt it. So then you can maybe knock it out with your skepticism. These kind of things of belief and skepticism have a very clear bearing on the efficacy of medicine, or there's the nocebo effect. You can take something that's neutral and make yourself sick because you think it will make you sick. The nocebo effect. That shouldn't be there. This is a very hot topic, not only the placebo effect, but this whole theme of neuroplasticity, which is getting very hot. Sharon Bagley wrote a marvelous book on this, Train Your Mind, Change Your Brain. it's first-rate science. By any criteria, it's first-rate science. Showing how experience, thoughts, emotions, imagination, visualization have quantifiable, measurable impacts on the brain, the immune system, the body as a whole. But it shouldn't have been that much of a mystery. You want to say something really weird? I did that. I decided to raise my hand. And then I put it down. I had this thought. And then it went into a desire, and the desire went into an intention. You want to see it again? Mind over matter. We can run that experiment a number of times just to make sure that you saw it wasn't a quirk. It wasn't an anomaly. There was no tricks. There was no hidden wires here. Mind over matter. Let's go back to history. Galileo, I love him. Want to read a really good book? Read Galileo's Daughter. Delightful book. Galileo took this bold step. I think he's the paradigm of a modern scientist. He was the template, much more so than Copernicus or others who preceded him, Tycho Brahe, more than Kepler. He brought in this theme of the rigorous observation of material phenomena, whether it was celestial phenomena, whether it was rolling balls down a ramp, a myriad of other terrestrial experiments that he did in the field of kinematics, dynamics. But it was not just observing, because Aristotle observed. He was not just sitting in his room philosophizing. He was out there observing. He was a great empiricist. But Galileo brought in sophisticated quantitative modes of measurement, the likes of which had never been used before. The telescope had never been used for astronomy. And with this unprecedented step of sophisticated, rigorous, sustained observations and, of course, experimentation, because he was a brilliant mathematician and an experimentalist and an observer, he truly, I think he more than anybody else, launched the first revolution in the physical sciences, in astronomy and in physics. He was marvelous. A bit arrogant, but gosh, he was good. And then Darwin, 1859, after about 25 years of meticulous, rigorous, very careful observation of biological phenomena in the Galapagos, in England, and various places, observing and observing, reflecting and observing more and reflecting, came up with his brilliant theory. But had he not spent those 25 years in very careful observation, if he'd just been a philosopher sitting in his room and thinking, gee, I wonder what happened, maybe it was evolution, that would not have been a scientific theory. It would have been musing, one more groundless hypothesis, one more philosopher's speculation. But he carefully observed in ways that nobody else had done, except for that guy Wallace. But Darwin did it better. And he launched a true revolution in the life sciences. And when I use the word revolution, I'm using it in a very specific way. When we speak of a revolution in the physical sciences, I'm saying once the revolution has taken place, you can never look at the physical universe in the same way again. Not if you got it, not if you understood the import of the revolution that took place. The Copernican revolution, the Galilean revolution, as soon as you get it, then the universe just looks different. Your take on it is just fundamentally different, and it won't go back. It might go forward, and you might, develop further, but it will not go back to what it was prior to the revolution, and likewise with Darwin. Seeing human existence embedded in an ongoing evolutionary process governed by natural selection, and now we know genetic mutation in relationship to a changing environment. As soon as we understand that, we cannot look at life the same way anymore. As static species that were plunked down someplace by something or someone. Can't do it anymore. We can't go back. It's fundamentally different. We are mammals. We are primates. And we can't back out of that.